Hello, everybody. We have started the last time with the Ricardo model and especially then with the definition of comparative advantage in opposite or not in opposite in relation to the general concept of absolute advantage, where we are measuring all goods in the same unit, while in case of a comparative advantage, we are measuring every good in a different unit. And we had this football example here that this relies on the opportunity cost concept, that we think we have different alternatives and we get them in a row, and then one alternative we choose to do, and the second best alternative, the utility which we would have from this second best alternative, this is then the opportunity cost of doing what we are doing. So right now you are sitting in front of your laptop or PC and listening to this lecture, and maybe then your opportunity cost is not sitting outside in a cafe or somewhere else. And within the Ricardo model, then we look at two goods we can produce with one production factor, which is labor. In this labor, we are measuring in time. And then we say that the opportunity cost of producing A using some time is not producing within this time an amount of B. So we ask then, how much less of good A can we produce if we increase the production of good B by 1 unit? So here then you see the different units of measurement. We are measuring the production of good A in units of B, and the other way around, the production of good B in units of A. Yeah, and then some further assumptions which we make in the Ricardian model. We do it quite simple. We just use a linear production function starting from the origin, and we just say, well, production amount Y is equal to some constant times our labor input, and this variable A is then nothing else than the productivity of labor, since we can just divide Y by L equals capital A, and then we have output per labor input. Or this term you will also quite often find that we write it the other way around with a parameter here then called small a or lowercase a, which is the inverse of capital A, and this is then the so-called labor coefficient, which is defined as labor input per output. So measuring labor in time means then, if the labor coefficient is, for example, 3, that I need 3 hours for the production of 1 unit. What we also assume is we, in our model, will have then 2 goods. So we can interpret this as 2 sectors. And then we are assuming that within these 2 sectors, we are totally flexible with our labor. So every worker can just switch from one sector to the other. He is as good in doing or producing good A as in producing B. And well, since we have this linear production function, we also directly see that we have constant returns to scale. In general, what is, I think that you already have heard, or have I done this before? Oh, it's okay. Um, what is meant by constant returns to scale? And assuming that we are producing with constant returns to scale is one of the core assumptions of classical trade theory. What is meant by constant returns to scale? Pardon? What is meant by constant returns to scale if we are producing with constant returns to scale? I suppose that you have heard about this in other lectures already. Yes, doubling input means double output, or 4 times input means 4 times output, and so on. And obviously, if we double the labor input, since capital A is a constant, 4 times labor input is 4 times A times 4 times A, and so we also obtain 4 times the output. And do you know why we in general make this assumption of constant returns to scale technology? Why CRS? Since you have heard this in other lectures, hopefully it was motivated why we are assuming constant returns to scale technology in general. We do it quite often. Yes, fully competitive markets there in the internet we have. Since we look at fully competitive markets. Well, and this means what is maximum profits in this case if we have constant returns to scale? Or have I already done this? Zero, of course. No, but I think I have also already explained it in my macro course. Isn't this true? Then zero profits are optimal. And why are zero profits compatible with fully competitive markets? Well, the argumentation behind this is if we have still the possibility of making profits, then there is an incentive for other companies to step into the market, and then we divide the cake of profits with more and more and more other companies. So it becomes less and less and less, and theoretically, in the end, in a fully competitive market, we should have only a very small margin of profits, or theoretically, in the end, of zero profits. So this is then the reason why we use here a linear function if we have only one input, one production input. Okay, that's for this. And then we want to start with our small little example. We look at two countries and we assume that the labor coefficients are given. So Portugal and UK both can produce wine and clothes, and Portugal should need 5 hours for producing 1 liter of wine, while UK needs only 3 hours. And if we look at the clothes sector, then Portugal needs 1 hour, while UK needs 2 hours. This is, or to use Portugal and UK, and this was also done 200 years ago by David Ricardo itself in order to explain his theory of comparative advantage. But of course, he interchanged who can what better. And therefore, I ask here, who has an absolute cost advantage in producing wine? Let's start with wine. If you look at this given labor coefficients. So we are both measuring both goods in the same unit in labor measured in time. So time is our unit. And which country needs less time to produce wine? UK, right. So UK needs 3 is lower than 5 hours to produce 1 liter wine, and then UK has an absolute advantage in producing wine. How is it due to the numbers with the clothes? There, you're right. Portugal. Oops, because I have only you. Needs 1 hour is smaller than 2 hours to produce one cloth, and thus Portugal has an absolute advantage in producing clothes. Of course, this is quite simple, and this is what we would directly look at. But now we want to go to the comparative advantage. For this, we have to calculate the opportunity costs. And remember, now we are measuring producing one good in units of the other good. So let's start with Portugal and if we are producing 1 liter of wine, how much, how many clothes we then cannot produce due to our numbers. We start with Portugal. Portugal and wine. So I need 5 hours to produce 1 liter wine, and I need 1 hour to produce one cloth. If I produce now 1 liter of wine, I will need, yes, and how many clothes I then cannot produce. For, or let me formulate it like 5, yes, for the production of 1 liter wine, we cannot, or Portugal cannot produce 5 clothes. So we are losing the possibility to produce 5 clothes, 5 pieces of clothes. And for UK, for the production of 1 liter wine, UK cannot produce how many pieces of clothes? 2? Well, we have here 3 hours for 1 liter of wine and 2 hours for the production of clothes. Yes, 1.5. So cannot produce 3 over 2 equals 1.5 clothes. Oh, sorry, I turned it the other way around. Here we have the opportunity. No, it's right. The opportunity cost of wine in units of clothes in units of wine. Here, then we are. And what do we have to do if we look at it from the other perspective? If we want to calculate the opportunity costs of clothes. What? Pardon? Yes, zero point 0.2. So 1 over 5, right? And 2 over 3, 0 point period 6. Okay, great. So then, since I do it digitally, I think I will do it like this. So then, for the production of one cloth, cannot produce 1 over 5 equals 1.2 liters of wine. And for UK cannot produce 2 over 3 equals 0.6 liter of wine. And here I really recommend that you redo it at home because you have really to be careful that you grasp this argumentation, measuring one good in units of the other good. Because quite often, if I pose a question in an exam and I say, here are your coefficients, then the students just say, well, it was just the relative number, and quite often they take the wrong relation. And what shall I do then? Because then I ask, I can only read what you have written. Have you understand it now, the model, or didn't you have understood the model? So please be careful using this. Okay, but now we have these opportunity costs. These are the opportunity costs. I'm losing 5 clothes for Portugal, producing 1 liter of wine, and my opportunity cost for UK is 1.5, 1.5 piece of clothes for producing 1 liter of wine, and the reverse for the other good. Okay, and now we look at what happens at first if the two countries only produce for themselves. Well, we have here a production process, and in general, we assume that the firms are profit maximization, profit maximizer. So what is profit? Profit is revenue minus costs. Revenue minus costs is the price of my good, wine or clothes, minus the costs to produce. This is the wage I pay for my labor, for my worker. So P times Y minus W times L. This is my profit. Well, now I just insert my production function. And remember, we have modeled our production as a linear function. Y is just L over lowercase a. And what we can just directly see in this case, since everything is linear, we do not have to take a derivative and setting this for 0, because we see here we have L in the linearly in the revenue part, and we have L linearly, of course, in the cost part. This we can take out of the brackets. And we know in optimum already profits are 0, setting the optimum level of profits to 0. Then we directly, since the L cancels out, we obtain the wage is P over A. And what is P over A? And now I remember the derivative, dy with respect to L, linear function, is just 1 over A. What is this? This is just the marginal product of labor. And this you have heard. What are you doing in optimum? In general, if you are a profit maximizer, is that the marginal value product has to coincide with the price of your input factor. This is the very general optimal condition you have, and nothing else is what we have here, because wage is just the price of labor. So on the left side, marginal product times the price is the marginal value of my input factor labor, and this is equal to the wage I pay in the sector. Well, this calculation now I have to do for both sectors. and in both countries. But now, for now, we do not assume that both countries are trading with each other. They are producing separately. So we look only what happens within these two countries. So let's see, for example, Portugal, but the same calculation is of course true for the United Kingdom. Then we have that the wage paid in Portugal in the wine sector is just equal to price of wine over the labor coefficient of wine. And the same is true in the clothes sector. And now remember, we made the assumption that labor is completely flexible. So I, for myself, can just decide, do I want to work in the wine sector or do I want to work in the clothes sector? So what does this mean now economically? Well, if in the wine sector the guy is paying me more per hour than in the clothes sector, what will I do? I just move to the wine sector. What will then happen if the guy in the clothes sector will still wants still to produce? He has to increase his wages. And what we then assume, remember, we are assuming fully competitive markets, that this is initiating an equilibrium process. And in the end, since we have here the price mechanism, as you know it from your introductory courses in business administration or microeconomics, that the prices start to change until we are in equilibrium. And here, due to our assumptions, in the end, the wages paid in both sectors has to coincide. Okay, so since labor is totally flexible and due to fully competitive markets, we have in equilibrium that both wages are the same. Well, and this now we just insert wage in the wine sector, wage in the clothes sector are the same. We had our conditions that wages are price over labor coefficient in both sectors. So this is equal to this. And we end up that the relative prices in every country is just the ratio of our two labor coefficients. In Portugal, we are exchanging 5 cloves with 1 liter of wine. And in the United Kingdom, we are exchanging 1 clove, uh, 1 liter of wine with 1.5 cloves. So this is the central outcome. Prices equals the opportunity costs which we have derived when we have talked about the comparative advantage. So this I already have said. 1 liter of wine in Portugal equals 5 cloves. 1 liter of wine in UK equals 1.5 cloves. And the relative price equals opportunity costs equals the exchange ratio of the two goods within the two countries. So, and now we can ask ourselves, what will happen given these two exchange ratios if the two countries are opening their borders? Well, why should they start to trade? Let's look at first from a perspective of Portugal. In Portugal, we have the exchange ratio of 5:1. So for 1 liter of wine, so to speak, I have to pay 5 clothes. If I find now somebody, let's say then on the world market, who sells to me 1 liter of wine for less than 5 clothes, then I will do it. And let's assume there at the world market we have an exchange ratio of 3:1. Then I will do it. Then I will be happy. Now let's take this exchange ratio on the world market of 3 and let's look from the perspective of the United Kingdom. There we have the exchange ratio of 3:2. So this would mean if I have produced wine, then at home I get 1.5 clothes, piece of clothes for this. This is my home exchange ratio. If somebody pays me for my liter of wine more than 1.5, then I'm also happy. Here we have assumed that the exchange ratio at the world market is 3. So I have an incentive to sell my produced wine at the world market for this higher exchange ratio. The other way around, I, in Portugal, have an incentive to pay this price because at home I would have to pay more than this 3 clothes. So both countries have an incentive to exchange goods with the ratio 3 clothes for 1 liter wine. And how do you call in business administration such a situation? If you start from a situation given and after an exchange, a reallocation, everybody is happy. This is just a win-win situation. So here you see automatically for both countries, it is a good decision to specialize in the production of this good where I have this comparative advantage. Because in order to be complete, I can look at this also in the perspective of the other good. Now, a British consumer wins because he can now buy clothes the other way around, not for a price of 2/3, but for a price of 1/3. Portugal has produced clothes because they have there the comparative advantage. At home, they can sell it only for a price of 1/5, 0.2 liters of wine. At the world market, they obtain 1/3. So overall, both countries have an incentive to specialize in the production of that good where it has an comparative advantage. And in the end, we have this win-win situation after trading. Oh, this I should also write down and trade afterwards. Well, and here we can have a look at the actual situation. In order to generate these profits for everybody, it has to be possible to trade freely. Well, this is the assumption behind of all. It works only if within the overall framework we have free markets. And now look at the actual situation. We have explicitly, especially the guy in the White House who said, my favorite word is tariff. Well, there's also a short paper, 1.5 pages, with I think 3 sources, where they claimed that they are theoretically explain why their tariff policy is good. I would say just enter any international trade lecture in the world, and then you will see that your argumentation is totally bullshit. Actually, I read this paper and then I wrote a little paper with a colleague of mine about it. And in one footnote, then I said, well, if you hand me such a paper from the White House as a term paper, then you will not pass because you have not understood anything about trade theory. Well, you could argue I'm the most powerful country and the most powerful man in the world and I can do what I want. Okay, this I have to accept. But if you are going to the world and you are claiming that you are explaining something and that you are theoretically right, and it is not. What do you mean? Again. Well, this is you will see if you go, for example, to the webpage of the World Trade Organization. So this is the introductory statement. Why? And we found it after World War II, the World Trade Organization. And yeah, the argumentation behind this is all our scientific stuff of the last 200 years, where clever people have thought about how should we organize our societies, our living in the world. And then, well, in general, we found these frameworks would generate a situation of, again, win-win situation. Everybody in the end is better off. Well, let's say after World War II, the first decades, we had it more or less, especially in the relation between Europe and the United States. Also, since I mentioned it in the beginning, when China entered the global markets, so in the beginning of the 90s, then with full speed at the beginning of the new millennium, they also started to or to open their country, their markets. But it is a pity for around 10 years, a little bit more. They also started, well, now we are so powerful, and let's switch again in a policy which is, yeah, more focusing only on their own country. Well, we have we have to accept this, that it is like this. But on the other side, we should, well, now, especially we in Europe, we have to accept this, especially we have slept very long, and that we now especially have to rely on the military power of the United States. This is a pity. We have not invested in this. Um, so we have to deal with their behavior. And this also means, and this I also have put here, I think, where it was. Yeah, here. That we are now in a scenario called de-risking and decoupling. So we are pushed more or less into the state that also in Europe we have to focus more on ourselves. Not because we want this, but especially because China is doing this and the United States is doing this, are doing this. And but we should not end with the argumentation and accept this situation. I hope that we still would argue, well, let's start over and over again to think about this situation. If we are not doing this, then everybody could be better off. Well, especially during this time of globalization in the let's start. I think I have read a study starting from the 99, roughly 1990 until 2010 or 2015, I think was the time series. And there you saw, if you have looked at the poor countries in the world, in Africa, in Southeast Asia, very poor countries. There you are measuring poverty in general. You are measuring how many people have only one. The first was $1. Now, due to inflation, we are measuring poverty in very poor countries. How many people have only $2 per day? And this number, since the beginning of globalization, since a scenario of more or less free trade, this number went down by 50% within 15 years. Very, very fast. Well, of course, we have many problems, and it's not everything good. But it really helped to get out the poorest people in the world out of poverty. And now, if we look at all these wars and this de-risking, decoupling, focusing only on yourself, that we also see that this ratio of poverty start to rise again. And that's really a pity for, in the end, all of us. But let's go back to theory, because I will do this Ricardian model with you also with other representation. And there, let's look at two producers called Robinson and Friday. Maybe you have read about them. This is a quite famous book. Who hasn't read this? Robinson Crusoe, a noble man from the United Kingdom, went out to the South Sea with his ship, and then uh, came into a storm, and then he was sitting on one island. Well, and then he had to start somehow to live on this island alone. And what I gave you here is just his production possibilities. So in order to eat something, he could spend his time or a day, totally climbing on a tree and picking coconuts. And if he does this the whole day, then he could pick up 9 coconuts. And if he would only catch some fish the whole day, then he could fish. Then he could catch in total 6 fishes. Or he could split his time, half a day climbing on the tree and half a day standing in the water, and maybe 2 fish, or not maybe, then he could also choose a basket of 2 fish and 6 coconuts. And you see here, I constructed it again, going down by 3, going up by 2, that this is also a linear dependence. And you can assume in between these intervals, you can extrapolate the production possibility also linearly. Well, and then in this book, it is told that at some day, some cannibals came there and then they want to eat somebody. And Robinson freed this guy. And since they couldn't talk to each other, he just named him Friday. Well, and now this is different to the other example I gave you, because if you look at the example of UK and Portugal, there you see that the absolute advantage has coincided with the comparative advantage. So the incentive for trade, we could argue also over the argumentation of absolute advantage. Because remember, UK had to spend less time in the production of what was it of wine, and Portugal in the production of clothes, and the same was true for the relative argument with the comparative advantage. But now you see here, Mr. Robinson is the noble guy from UK. He was in his younger times not really used to catch fishes or to climb on trees. But the guy Friday, he grew up in the South Sea and he has learned how to do this. And so his possibilities are that he can at maximum pick 30 coconuts and 10 fishes. And also just linearly here you see we go down by 6 and we go up by 2. So also this linear dependence. So then we can conclude Friday can produce both goods better than Robinson. Why should they trade with each other? Well, maybe Friday is quite thankful because he has not been eaten by the cannibals. This could be an incentive, but if he just sees how um, Robinson tries to catch a fish, he said, wow. Or how he is climbing up the tree, he also says, well, let me do it. Why should they trade? Well, for this, let's use a graphical representation of these two production possibilities. This I do not need. Zip up. And let's see what they can produce if they work only alone or if they work together. Is it not working? This one? Is it only working with this? Now my mice is gone. What have I done here? Now I have it. There it is. So up. Hmm. Okay, let's use here coconuts and fish. And since in the end, you will be not surprised, we will look at the possibilities if they work together. So overall, we just look at the maximum amount they could produce together. So here we would have 6 and 16. So then let's say 5, 10, and 15 for the amount of fish. And 9 and 30 is 39. So 10, 20, 30, and 40. So how can I represent now the production possibility for Robinson? Well, since I know that it is a linear dependence here, I just can look at 2 points, and I know that a straight line is defined by 2 points. Then, since I'm stupid guy, I just use the extremal points. I could produce 9 coconuts, no fish, or the other way around. What do I have here? 6 fish and 0 coconuts. So my production possibility would be then just the linear line between these 2 points. How does it look like for Friday? Here I have 30 coconuts. Yes, and yeah, go on. 0 fish. Yeah, yes. So I'm just here. So this would be this flatter line. So now we can ask ourselves if they are working together at maximum, how much fish could they produce? If they are staying the whole day in the water just catching fish, how much fish can they catch at one day? 16, right. So we are just here, 16. And how much coconuts could we pick? 39. Great. And now is the question, well, how are looking the production possibilities in between? And for this, we, for example, can ask, we are starting with this extremal point, only catching fish. If they are talking to each other and they say, well, it would be quite nice to have some coconuts, and who then should start to climb on the tree? And now comes in the argumentation via comparative costs. Because they are talking to each other, the first thing would be, okay, I know Friday can everything do better than I. But is this really true in the argumentation of comparative advantage? Because when they are talking to each other, then they can just ask, well, let's think about it. Who should start it? Because if now one of these guys is starting to climb on the tree, picking one coconut, in this time, he cannot catch a fish anymore. So we are losing fish for the first coconut. So the question is now, how much fish is Friday losing for the first coconut? And how much fish is Robinson losing for the first coconut? So for one coconut, Friday loses how much fish? If you look here at his production possibility. Now, he is only increasing to one coconut. So he starts, let's say here, from this production point, And now he is increasing the 0 to 1. By which amount is then the fish decreased? By 2. So this would mean when I'm reducing the fish production as Friday by 2, then I can pick up 6 coconuts. But I want only 1 additional coconut. Can the internet help me? Pardon? Or let's take it the other way around. Reducing my production of fish from 10 to 9 means I can pick up 3 coconuts, okay? So, but now I want to have only 1 coconut, not 3. So it is, no, not 1.5, but 1 over 3. Yeah? Because if you look at the total amounts here, the exchange ratio between the two goods is 30 over 10. So it's 3. So increasing my production in coconuts means I'm losing 1/3 of fish. How does it look like for Robinson? For 1 coconut, Robinson loses 0.3. Yeah, almost 0.3. So 3. You're right. Thank you. And maybe you can then answer me the question, what is the situation for Robinson? If he would pick the first coconut, then then he is losing. So starting from this point here and increasing to 1. 2/3. Great. Because here we have the exchange ratio 9 over 6. Well, and now we are assuming they are working together, so they are talking to each other. So they are produced for their both demands. And then it should be clear that at this point, Friday should start in the production of coconuts. Because then overall they are losing less fish compared to the situation if Robinson would do it. Well, and now he can increase his production until his full capacity. Full capacity is 30, and this would then geometrically mean, oops, there it is, that we just move in parallel. Oops, I have to copy this. In parallel, the production possibility of Friday upward. This then means I'm ending up here. So the reduction of 10 until this production point, 630. Then I'm at full capacity. If I now want to have more coconuts, since Friday is at full capacity, we have to add the production of Robinson, and this then would mean that we move horizontally the production possibility of, oh, it almost works out. Robinson. So in general, in order to get, the aggregated production possibility for both means to move horizontally the steeper production possibility to the right and vertically the flatter production possibility upwards. So let's summarize this here. So this means Friday has a comparative advantage at oops, in producing fish. And from the other example, we already know the comparative advantage just is inverted if we look at the other good. And Robinson has a comparative advantage in producing. Oh, sorry, Friday in coconuts, of course. Sorry. Here you see, you have to be really careful. You just interchange this. Um, Coconuts in producing fish. And what we also can say, well, the slopes of these two production possibilities. So in general, these are the production possibility frontiers, or since they represent the exchange possibilities between the two goods, it is also called the transformation curve. And the slopes of the transformation curves represents the exchange ratios in the two countries. Well, and now, since we know Friday has an incentive to exchange one fish with 3 coconuts, and Robinson has an incentive to exchange 2 fishes with 3 coconuts, we can again, as compared to the other example, is there an exchange ratio of the two goods where they have both then an incentive to specialize due to their comparative advantage and afterwards to trade? And of course, again, this lies in between these individual exchange ratios. So assume an exchange ratio of one fish for 2 coconuts. Well, Friday has the comparative advantage in producing coconuts. So he has the coconuts. If he wants to have a fish, then he loses 3 coconuts. So if he has already produced the coconuts and there is another guy, Robinson, who sells to him 1 fish for only 2 coconuts, then he is happy. The other way around, he has the fish produced, Robinson. If he wants to have a coconut, he, for reducing the production of fish, he can pick up 1.5 coconuts. If he gets for his fish more than 1.5 coconuts, then he is also happy. So this ratio is in between the individual ratios. So both have an incentive to specialize due to their comparative advantage and trade afterwards. So and now let's look. The specialization point is just this point here. Friday produces this 30 coconuts and Robinson is producing 6 fish. This is the point 36 coconuts and fish. Now let's take within this point this exchange ratio. This exchange ratio means that we have a straight line with a slope of -2. Oh, sorry, we have this the other way around, this by -1/2. 1 coconut for 2 fishes. Sorry, yeah, again, the other way around. 2 coconuts for 1 fish. So moving 2 units to the right means going up 1 unit in the vertical direction. So straight line with slope 2. Then we can ask, a slope of 2 is a little bit steeper than the blue line. This has a slope of 1/3 and a little bit flatter than the red line. This has a slope of -2/3. So it will be looking somehow like this. And now my question is, where's the outcome at the horizontal axis and where's the outcome at the vertical axis? Because this would then mean this is then we are valuing this basket here in units of coconuts. Well, within this basket, we have already 30 coconuts. So a value of 30. With an exchange ratio of 1 fish for 2 coconuts, What is the value of 6 fish measured in coconuts given this ratio? How much coconuts do I get for 6 fish given an exchange ratio of 1 to 2? How much? 6 fish have what kind of value measured in coconuts? Hmm? I have to pay 2 coconuts for 1 fish, and I have 6 fish. So 12, of course. So the value in coconuts of this 6 is 12. So the outcome here would be then 30 plus 12 is 42. 2 times 6. This is the value of the basket 3, 6 measured in coconuts. So, and now of course, we go to the vertical axis. What is the value of this basket measured in fish? Of course, we have already the 6. What is the value of 30 coconuts measured in fish? Again, giving this exchange ratio. Again, value of 30 coconuts. So I can ask how much fish can I buy with 30 coconuts if I have to pay 2 coconuts for 1 fish? 15, yeah, of course. So the value of this 30 is 15. 15 plus 6 is 21. Maybe roughly here. So why did I draw this line? Well, what we now see is, so to speak, the overall profit, the profit of the world working together, trading with each other, compared to the situation of autarky. If everybody is producing only for themselves, then measured in the units of fish, they are separately have the possibility to produce 16 fish. If they are working together with an exchange ratio of 1 over 2, they can produce a basket overall with an overall value of 21 measured in fish. So then 21 minus 16 is the overall profit of working together measured in fish given 1 fish for 2 coconuts. Or down here, 42 minus 39 is the profit of trading measured in coconuts, again given this ratio. Now the processor is down then, since I have written that much. Does it work? No. Then let's stop this. Oops. Nuts given 1 fish for 2 coconuts. Just give me one other minute, because I also want to show you a last thing which we can see within this model and this representation. So this line then represents something like the total income. So measured in fish, the total income is 42. In coconuts is 42 and 21 in fish. So total income line. We could also say, well, our aim is overall to maximize the total income of the world. So any possible or any income line with a slope of 2 would be all parallel lines compared to our dotted black line. So what also would be one possible income line is this: from 30 to 15 has also a slope. Well, this is possible income line because it is below our production possibility our production possibility frontier, because every basket lying on this income line is within our production possibilities. Well, and what are we doing quite often in economics? We say we have some restriction. The restriction is now our production possibility frontier, and then we are maximizing our aim. Our aim is our income line. So we try to move out this income line as far as possible. Well, and since we have here this concave form, so first the flatter and then the steeper one, then it's clear that we can move out this income line up to this point. So this represents then maximum world income. And in the end, this is conceptually the same what you have done in microeconomics. You had a budget line given the maximum real income measured in the two goods. You had your indifference curve, possible indifference, possible utility levels. And what you then said, well, I just want to move out this indifference curve as far as possible until just the point where you just be tangent on the budget line. Well, since you have here a discrete problem, it is not tangent, but it is the most far outward lying point you can reach here. And since you have here a linear problem, then maximizing in such a way, this is called, since we have a linear problem, is linear optimizing. And in general, if you think of many restrictions, then it is not that easy as in this case. And for this, we have the so-called simplex algorithm to find this maximum point. And well, sometimes this is done in the introductory courses in mathematics. I don't know if you have seen linear optimization processes there. Because this you also find in business administration course. I have learned this in my business administration course, introductory course 2, when I have studied. So you think of just within a company of linear production possibilities for, let's say, 15 different goods. And then you want to know what is my optimal production plan in order to optimize revenue. And revenue is just price one times quantity one plus price two times quantity two and nothing else we have done here. So the concept is also used in the optimization processes within companies. So that's it for today. Thank you very much.